Hi, hello everyone. Welcome back to my YouTube channel Sporify Learn. Today, let's continue the second exercise of first chapter, relation and function. That is first question. Let's see on. Show that the function f r to r defined by f of x is equal to given as 1 by x. Okay, and we have to show that it is 1 1 and onto, where r is the set of all non-real numbers. If is the result true if the domain is r is replaced by n. We have to replace the r by n, that is natural numbers, with codomain r. Codomain we have to keep the same. Okay, now let's see on what we have to do. See, the function given is 1 by x, right? That to prove it is 1 1, see, 1 by x, that is f of x, right? This is given function as, and you have to keep the function as f of x is equal to something as f of y or f of z, something you can take in function place. Okay, and you have to show that they both are equal. If they both are equal, it is said that it is 1 1. See, 1 by x is equal to 1 by y. So if you see, x is equal to y. Okay, so this is called as 1 1. Let's see for on to. See, f of x is given as what? 1 by x, right? X you replace as 1 by y. Okay, x you are replacing as 1 by y. Okay, 1 by y. Now you see that this 1 and 1 will get cancelled and this will come up here, right? This is 1 by 1 by y it is, right? So if you bring this up here, it will become y. Here 1 and 1 will get cancelled. So the answer is onto, because we are proving that f of x is equal to y. Now let's see on, that is 1 1 and on 2, and they have said as n r you have to replace with n. So write the function g is to n r defined by g of x, like something function you have considered as g, right? So consider it as g of x is equal to 1 by x, and g of x1 is equal to g of x2, that is 1 by x1 1 by x2. 1 by x2 replace with x1 and x2, so x1 will be equal to x2, so that is 1 1. For on to, here you are taking, see, to prove that it is not onto, see, 1.2, some integer value you are taking. Okay, 1 by 1, 1.2, that is not a whole number, so it is said that it is 1 1 but not onto. Okay, hope you have got this. Now we have to check whether it is injectivity and surjectivity of the following function. See, they have given us n to n, that is natural number. F of x is given as x square. Okay, now let's see. F of x is x square is the function that they have given, and now let's see on, it is said that x comma y, that is x comma y, some function x comma y belongs to n, because they have given here natural number, and f of x is equal to f of y is equal to x square is equal to y square. See, some you are taking function x as y, so it will be y square, right? This will be x square, this will be y square. So if you cancel square roots, it will be y, or you can apply root on both sides, square root and root will get cancelled, so it will be x equals to y. So it is injective. Okay, if x is equal to y means it is injective. Okay, now let's see next what they have given to prove for surjectivity also, right? So when 2 belongs to n, right, 2 is natural numbers as we all know, but does not exist in x square is equal to 2. No, now root 4 is equal to 2, but root 2 will not come for any value, it will be some decimal, something like 1.1 or etc. It will be decimal value if you take. So now it is said that it is not surjective. Okay, it is injective but not surjective. Let's see on to the next question, that is integer they have given an x square, the same function. If you take f of minus 1 and f of 1 is equal to 1, but minus 1 is not equal to 1, right? Minus 1 is not equal to 1. If you have to take here, you considered as f of x and y, they both are variables, they both are positive variables, and some variables you have considered here. Minus 1 and 1 you are considering, so it is not equal, they both are not equal, so we say that it is not injective. Next, you take minus 2, that is integer only, right? Minus 2 is integer. If you take minus 2, minus 2, root of minus 2 is not existing, so, or it may come value such as minus 1.1 or something like that. Let's see what's the value of root of minus 2. That is not valid point, So that is said that it is not surjective. Okay, it is neither surjective nor injective. They have given us rational number. Okay, and if you take x square, f of minus 1, f of 1, see minus 1 is not equal to 1, so you cannot take, because you are considering minus 1 and 1, so you cannot take. If 1 you disprove also, it is said that it is not. Okay, now next is for surjective, you are taking again minus 2, and same root of minus 2 doesn't exist. So it, we will get some math error or some errors we will get if we do this type of minus root something. So it is said that it is not surjective. Next they have given is x cube. Here what you have to observe is they have given us natural numbers, and f of x is equal to f of y is equal to x cube y cube. So it is injective. X cube is equal to y cube. Cube and cube root will get cancelled. So you will get as x is equal to y. Now next they have given for in surjective is they are giving natural numbers, right? You take two only natural number, but there does not exist any element x in domain, like f of x cube root. When you are taking cube root of 2 is not existing. Cube root of 8 is 2. Okay, you try to understand what the concept I am saying here. The cube root of 8 is 2. Okay, sorry, here 2. Okay, but cube root of 2 is not existing. 2 cube may be existing, that is 8, but cube root of 2 is not existing. So we say that it is not surjective. Okay, next is it is injective but not surjective. If you consider integers and this x cube y cube, it is injective but not surjective, because same root of 2, cube root of 2 is not existing. Okay, it is injective but not surjective. Now next we have to show that greatest integer function f is to r, f of x is given as x, okay, is neither 1 1 nor on 2, where x denotes the greatest integer less than or equal to, it is less than or equal to x. Okay, now let's see the function they have given here is x. Okay, now you take some function, you can take random numbers. 1.2 here, because they are saying it is rational numbers, you take 1.2. 1.2 is having 1. Okay, they have given x, right? So you consider as 1. 1.9, 1.9 will be also 1. So 1.2, you are considering 1.2 and 1.9, they both are not equal, so you say that it is not 1 1. If you consider 0.7, 0.7 means f of 0.7, f of x you considered as 0.7. Okay, now it is not equal to any element, so we say that it is not onto also, it is neither 1 1 nor onto. Next, you on to the next question. Show that the modulus function f of is to r, f of x given by x. Okay, this is modulus function. Here we discussed as greatest integer function. Okay, is neither 1 1 nor onto, where x is having positive 0 or x is having minus if x is negative. Okay, now let's see, there will be two possibility here. They have given as greater than or equal to 0 means what? It is positive or the value is equal to 0, so you consider it as x. Okay, if it is less than 0, obviously it is understood that it is negative numbers. Now if you consider some f of minus 1 of minus 1, I have said in previous video that mod of anything is positive itself. If negative number is there also, it is positive. F of 1 is equal to 1, say both are equal, but here you can observe that f of minus 1 and here f of 1, so they both are not equal, right? So it is said that it is not 1 1. The values are equal, but the function which we are considering is not equal. Here we considered as minus 1, here we are considering as 1. No, it is not equal, so we say that it is not 1 1. You consider minus 1. Okay, minus 1, and it is always negative. Okay, yeah, it is known that positive, like if you want to find modulus, use is only if you have any integer or any value, you make it positive, is the work of modulus. So it is always non-negative, right? The value of modulus before value is negative, but here it is non-negative. Thus there does not exist any rational number such that x is equal to minus 1, so it is not onto. Okay, minus 1 is not present, so it is not onto. It is neither 1 1 nor onto. Now they have given signum function. Signum function is the 1 if it is greater than 0, that means positive. If it is equal to 0 means it is 0. If it is minus 1, that is negative. Okay. We have to show that it is neither 1 1 nor on 2. See, you consider f of 1 is equal to f of 2. 1 is not equal to 2, right? So you consider it is not 1 1. They have given the function is rational numbers. Okay. Next, we you take the values of three values 1, 0 and minus 1, and in codomain 3. R is the codomain, right? Minus 2 is not existing in codomain. So we say that it is not onto. It is neither 1 1 nor onto. Next, we have to show that let A is equal to 1 to 3 some set given, b is equal to 4 5 6 7, and f is the function they have given is 1 4 2 5 and 3 6. It is a function from a to b. Okay, show that f is 1 1. To show f is 1 1, what we have to do is now write down the set which they have given, and f is function from, you have to write this. See, function is f, they have named, right? F, and they have mentioned from a to b, a to b is defined as what the function they have given, this write down here. Okay, f of 1 means f of this 1 is equal to 4. Okay, the value they have given, this is the value of x, this is the value of y. Okay, f of 2 is 5, f of 3 is 6 they have given, and it is seen that the images, it's seen that the images are also present between them. Okay, a, they both are also distinct. Okay, so we say that it is 1 1. Next, see the seventh question. They are saying in each of the cases they have given two questions. State whether it is 1 1, on 2 or bijective. Okay, let's see the first question. They have given function is 3 minus 4x 3. 3 minus 4 x1. You consider for x, x1 and x2. They both are equal. 3 3 will get cancelled, and minus 4 1 is x1 is equal to minus 4 x2 will be there. Plus it will also be get cancelled. 4 4 will also be get cancelled. So x1 is equal to x2. So it is said that 1 1. Next, see, for in the place of, see here they have given as f of x is equal to 3 minus 4x, right? See, now you have to make this x place y. That means f of y will be equal to 3 minus y by 4. You can make this is multiplication, right? These both are multiplication. So you have to make it division, okay? That you can make as divided by 4. That means 3 minus y by 4 is equal to 3 minus 4y. 3 minus 4 of y. This means it is y, right? The in the place of this y we are substituting the whole value. Okay, 3 minus 4 times if LCM you can take, and you can do, the value will be 4 4 will get cancelled, 3 minus 3 will be 1, sorry 0 0, minus y will be, and here it is minus of minus y will be plus y, so it is on to, it is bijective. If it is 1 1 and onto, we say that it is bijective. Here also same, x place you replace x1 and x2, you will get x is equal to plus or minus. See, if it is square means it should be either plus or minus, right? It should be plus or minus. So it is said that it is not on 1 1. You can take plus 1 value minus 1 value means it is not equal. Function value is not equal. Their value may be equal, but the function value is not equal. So we say that it is not 1 1. And next, the value is same, 1 plus x square you consider, and if you take some value as negative minus 2, the value is not present in the domain, so we say that it is not onto, it is neither 1 1 nor onto. Next is let a be, they have given a set as a comma b is bijective, we have to show. Okay, a1 b1 you consider as b1 a1 b2 a2. Okay, they both are equal only, right? A1 b1 a2 b2, b1 b1, b1 is equal to b2, a1 is equal to a2, so we say that it is 1 1. Next, um, they have given as f of a is equal to ab is equal to b of a. Okay, by definition of f here they have given, right? So now we can say that they both are equal only, right? So we say that it is onto, you write the function what they have given. And next, see the ninth question, that is natural numbers. Function is given 2 function, if it is even and odd, all belongs to natural numbers. Okay, now we have to show that it is bijective or not. To show bijective, it should be 1 1 and on to both. Okay, now let's see on if you take 1 in x place, here n they have given, right, in n place, so you can take as 1 plus 1 by 2, that will be 1. F of 2 also it will be 1, so it is the value of them is equal, but the value of the function is not equal, right? F1 is not equal to 2, so they say that it is not 1 1. And if you take case 1, n is odd, right? They have given two cases, n is odd and n is even. If you take n is odd, you will get as 2r plus 1. Now 3 you should get, right? 3. Okay, 3 is the odd number. Okay, now you should do 2 into some r plus 1, right? 2 into 1 plus 1 will be what? 3. So in that place you write as r. Okay, next the same way you will get 2r plus 1. Here for even it will be 2r, because even is 2 into 2 will be what? 2 multiples are even, right? 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is 6, 2 into 4 is 8. The same way you have to do. 2 multiples are even, so we say that it is 2r. So it is not bijective, it is not 1 1, so it is on 2, but it is not bijective. 1, because 1 1 is failed, but on 2 is agreed, so it is not bijective. Let a is equal to r minus 3, b is equal to r minus 1. Okay, f is function a to b, and they have given function as x minus 2 by x minus 3. If is function 1 1 and on 2, see, x minus 2 by x minus 3 is equal to y minus 2 by y minus 3. See here 2, you can solve in this way also. You can cross multiply, right? If you cross multiply, you will get the same. And if you solve this equation, here also 3x 3, here also 2 2 2 will get cancelled, 3 3 will get cancelled, x will be remaining, x is equal to y will be remaining, so it is 1 1. For on 2 you have to show that it is y, right? So x minus 2 is equal to xy minus y. Okay, xy minus 3y. So if you can take x common in both term. Okay, now x of 1 minus y will be remaining, x minus 1 minus y is equal to minus 3y, you remain as it is, and here you bring this 2 here, it is minus 2, it will become plus 2, so it will be the value as 2 minus 3y divided by 1 minus y, which belongs to a. So there exist element, so if you show that it is onto, it is said that it is bijective, it is bijective. Next question is, f is equal to x power 4, choose the correct answer. F is 1 1 on 2, f is many to 1 on 2, f is 1 1 but not on 2, f is neither 1 1 nor on 2. See, if you take x power 4, is x is equal to plus or minus, so we say that it is not 1 1. As we can see, it is plus or minus, we say that it is not 1 1. So the answer may be, it is neither 1 1 is here, it is 1 1, no, this answer is not there, so only the possible answer is D here. Okay, you have to do elimination method in MCQ. See, if here only we got the answer as not 1 1, right? So the option is here 1 1 they have given, so this not possible at all answer. Okay, now see, wait. See, now this is not possible because they have given as 1 1. Okay, this is also they have given 1 1, so this is not possible, and this is also given as 1 1. Many to 1 they have given, many means many is considered to one domain. Okay, so it is also not possible, only the answer is neither 1 1 nor on 2 is this answer, so you can check that. Okay, next they have given is, what is the, choose the correct answer, again same, and they have given as 3x. Okay, as we can see that 3x, right? 3x they have given, x1 is equal to 3, x2 you can do, or 3 3 will get cancelled, x1 equals to x2, so we can say that it is 1 1. Yeah, this is here, here it is, this option you can eliminate, it is also not option. Okay, now let's see for on 2. 3x, right? They have given, you have to prove that it is y. Now you consider f of x is equal to y. 3x is equal to y you will get. So x is equal to y by 3 you will get. Okay, y by 3, and the function they have given is rational numbers, so it is present, so it is on to. The answer is option A. Here you can see it is 1 1 and on to. Answer is option A. And let's discuss the next exercise in the upcoming videos. Stay tuned. Thank you for watching.